Alright guys, molecular geometry, chapter 9, section 1. Yes, I know, Allie, that's the way I start every video. Get over it. Here we go. Alright, so molecular shapes. We're talking about the shape of the molecule. And electrons dictate the electron shape. Here you'll notice that we have 1, 2, 3, 4, 5 different kinds of shapes. Okay? And what we have to look at are these electrons. So here's a Lewis dot structure. And we've got bonding pairs and we've got a non-bonding pair. Okay? And so to do this, you have to draw a Lewis dot structure. Okay? Because you have to know where those electrons are. The deal with the electrons and why they dictate it is because they want to be as far away as possible from each other. Okay? They spread out because they repel each other. Electrons repel each other. So that's how they dictate the shape. Okay? All right. We can refer as electron pair to we can refer to electron pairs as electron domains. So here's a molecule. Let me count up the domains for you. Okay? Here is one domain because that is an electron pair. Here is another domain. Here is another domain. Here is another domain. So far we've got 4 domains. This is a 5th domain because it is a pair of electrons. Okay? Here's a domain. Here's a domain. So basically we're counting up domains, pairs of domains. Now, when we're trying to figure out the shape though, we are only counting up domains on the central atom. Count domains on central atom only. Okay? So on this central atom, we've got 1, 2, 3, 4 domains. Now I know what you're thinking. You're thinking, but you said electron pairs. Well, because these are all together, we count them as one domain. Okay? All right, so valence shell electron pair repulsion. That's pretty fancy. VSEPR for short. What you have here is you have a carbon tetrachloride molecule. Okay? Basically what they're saying is that molecule takes this overall shape. Because look at these electrons. They are as far as they possibly could be from each other. And then this is what the molecule actually looks like. Okay? If we count up domains on this, there is 1, 2, 3, 4 domains. Now, take a look at what it says over here. It says number of electron domains. Well, we just said that on this one there were 4. So that means the electron domain geometry of this is called tetrahedral. Okay? When you have a tetrahedral, your bond angles are going to be 109.5. That means that between every atom that's connected to the central atom, there's an angle. If we measured it with our little, what is it called, a protractor? Protractor, yeah. There is a bond angle of 109.5. Okay? All right, so molecular geometry. Okay, molecular geometries. Within each electron domain geometry, there are different molecular geometries, okay? I know, it sounds crazy right now, but here's molecular geometry. It'll be okay. Just hang on. Let me show you this next one. Okay, so here you go. This guy right here is a trigonal planar. Its electron domain geometry is trigonal planar. If we were to count up the number of electron domains around the central atom, it would have 3. Okay? So 3. Now, here's the thing. When we look at it, we have to count up bonding electron domains and non-bonding electron domains. Okay? So, if it is like this atom right here, this one has 1, oh, I didn't change the color, 2, 3 bonding domains. So all of them are bonding. So we know that the shape of that is going to be just like this, and we call it trigonal planar. Okay? This atom right here, sorry, I forget you guys aren't with me, right here has 1, 2 bonding domains, and its third domain is a non-bonded domain. So its shape is going to be bent, okay? And then over here there's 2 examples. Boron trifluoride with its 3, hello, pen, work, 3 bonded domains, and then down here we've got NO2 with its 2 bonded domains and its 1 non-bonded domain. Okay? Oh, I forgot we've got one more to look at on here. Here's another one. Okay, this one doesn't have the column for number of electrons or electron domains, but we can write them in. Obviously, there are 4 domains here, right? 4 total. On this one, there are 1, 2, 3 that are bonded. So we've got 3 bonded. And my pen's not working so well right now, you guys. 3 bonded, and we've got 1 that is non-bonded. Okay? It's going to look like this. We call it trigonal pyramidal. It is still a tetrahedral molecule. The bond angles here are still 109.5, but it's a trigonal pyramidal. On this one, we have 2 bonded spots and 2 non-bonded spots, so we call this a bent. Okay? All right, so how do you figure out geometry? Well, we count up the electron domains. Okay, so for this atom, electron domains is 1, 2, 3, 4. There are 4 electron domains. Okay, I'm going to say dome, even though that's not how you spell domains, but that's our abbreviation of 4 electron domains. Of those, so we automatically know if there are 4 electron domains, it has to be tetrahedral. Now, which type of tetrahedral is it? That's where we say, well, of those 4 electron domains, one of those is non-bonded. One non-bond. right, one, I was saying when it cut me off, one non-bonded. Okay, so no, one non-bonded. So this ends up to be trigonal pyramidal, but it's trigonal pyramidal within tetrahedral. It's still a tetrahedral structure, but it's a trigonal pyramidal tetrahedral structure. I dare you to say that 3 times fast. Trigonal pyramidal tetrahedral. Good luck with that. So it ends up looking like this. Okay? All right, so here's some more examples of molecular geometries. Woohoo! We have got the ones that have 2 electron domains. They're going to be linear. That's pretty much all there is to it. There's not much other place you can go, whether they're bonded or non-bonded. It's still in the shape of a line. If you have 3, it's a trigonal planar overall, but it can be trigonal planar or it could be bent. Okay? If you have 4, this is the same one I showed you, the same slide I showed you earlier. It's tetrahedral, but it could be tetrahedral trigonal planar or it could be tetrahedral bent. Okay? And the reason it takes that shape is because of the bonded and the non-bonded spots. All right? Okay. Now, you guys, you need to take a look at the sample problems within the book. They start on page 347. Let me write this down for you. Oh, hey, let's write in white. That would be fun. Page 347. And continue on 348. And then there is another one on page 351 that goes through 353. There's actually 2 on that page. One starts on 351 and ends on 352, and the other one starts on 352 and ends on 353. So, okay? So take a look at those. You'll be working on more problems in class. Have a good weekend. I'll see you on Monday.